We're going to look at taking indefinite integrals of general polynomials now. But before we do that, we need a couple of sort of general rules. Recall from last video, we talked about the power rule of derivatives, which of course is moving the exponent down and subtracting one. And then we constructed the power rule for an indefinite integral, which is what we're going to be using over and over in this section. So you add one to the exponent and then divide by that new exponent. And we usually have a plus c here to indicate that it could have been any constant being added to it because the derivative would take that constant to 0. Okay, so let's think about what we'll need for a general polynomial. So first thing we're going to need is a constant multiple rule. And the constant multiple rule for indefinite integrals is essentially the same it is for derivatives. We're sort of undoing the same thing. So if I take the antiderivative of this, oh yeah, maybe I'll use a different letter since we're using plus c. It's going to be the same. You just can pull the constant multiples out, right? So if we want to say something like, the function capital F of x is equal to little f, what this ends up looking like is k times an antiderivative plus c. Right. So it's the same thing as derivatives. The indefinite integral doesn't sort of change the constant multiples. It can just be factored out. The other thing we'll look at is addition. So the same thing happens here as does in the derivative case. If I have two functions added together, and I'm taking an indefinite integral, it turns out that I can just take the indefinite integral of the individuals, just like with derivatives, and just add them together, and that's the answer. So capital G prime of x we'll say is little g of x. So the answer we'll get out of this is, whatever the an antiderivative of f is plus whatever an antiderivative of g is plus c. So let's look at an example of this, and let's think about polynomials, but it turns out we're going to be able to do some things that are beyond polynomials as well. So let's do an example here. So let's take the indefinite integral. Let's just keep it simple. So let's do like 5x to the 7th or something. Just to sort of demonstrate the constant multiple rule. So it says here that we can just pull it outside. So I'm going to leave f outside, and this is multiplication. I'm multiplying 5 times the integral of x to the 7th. And now I can just take the integral using the power rule. So remember the power rule over here, we're going to add 1 to the exponent and then divide by that new thing. And then whatever we get out is going to be multiplied by 5. So it's going to be 1 plus 1 is 8, so x to the 8th, and then I'm going to divide by 1 over 8. And I'm always going to put the plus c out here. You could think maybe it should be in here, and it could be, and you'd have to multiply it times 5, but a constant multiple is a constant, a general constant is a general constant. Even if it's multiplied by 5, it's not really going to change what we're trying to say with it. So we'll always take the most simple antiderivative here and just tack on a plus c. So let's simplify this a little bit. So 5 times 1/8, we're just multiplying two fractions together. So it's going to look like 5/8. And so that's the indefinite integral of 5 times x to the 7th. So that's sort of how the constant multiple rule works. So what happens if I'm adding some stuff? So let's do like x to the 5th minus 3x to the 4th or something. Okay, so notice above, it tells us we can just break it into two integrals. So the first thing I might write is x to the 5th dx plus the integral of negative 3x to the 4th dx. And then maybe I should have done this in the first step, but really this -3 is only, we can pull it outside. And so could write it something like this. We have integral of x to the 5th minus 3 times the integral of x to the 4th, right? So I've pulled the 3 out because of the constant rule, and I've broken it up because of the addition subtraction rule. Okay. And, you know, this could be a minus. You could go ahead and pull the minus out here. It doesn't matter, you know, whatever works for you in this case. Okay, so what are we doing? We're adding 1 to this, x to the 6th, and then we divide by that new exponent. I have minus 3 times. I'm adding 1 to this, so it's x to the 5th, and then 1 over 5 is my multiple, and then I'm going to put my plus c out here for the whole function. So instead of doing 1 for each individual integral, I'm just going to pull 1 out here at the very end. Okay. So then I have 1/6 x to the 6th, no simplifying there. But here I can simplify it a little bit and call this -3/5. Okay. All right, so one more example I wanted to look at, simple example, using the power rule, and really it's without any power of x at all. So one question we could ask is, what is the antiderivative of the constant function 1? And you can think about this a few ways. I think the easiest way is to think about what thing has a derivative that's 1, right? So think of the function that has a derivative of 1. So what is that function? I think we can recall that that should be x, just x by itself. Okay, so the antiderivative of 1 is x plus c. Sorry about that. Okay, so then what happens if I take like the antiderivative of 2? Well, you can think about this a few ways, but if we use the constant multiple rule, if I can factor a 2 out, then this is just going to be 2x plus c, and so on. So any integral of a constant multiple is always going to be that multiple of x plus c, right? And let's do one last example just to drive this point home. So if I'm taking the integral of, like, say, 2x to the 5th, well, we already did that one, that's fine, minus 3x to the 4th plus x squared minus 7. So I'm going to break this down into 4 integrals, and I'm going to kind of do this all in one step. So maybe over here, if we know we can pull the constant multiples out, so I'm going to do that as I go, and I'm going to break these up into individual integrals for each term. And I'm not suggesting you do this every time. You know, you'll be able to do most of this in your head after we get a few examples in, but just for the sake of our first examples, maybe we'll do this. So add 1 to 5, you get x to the 6th, 1/6, right? And then we have the 3 out here. We go x to the 5th with 1/5. You know, this is just 1/3 x cubed. This is straight up power rule, no constant multiple. And then I have minus 7, and then the integral of that is x. And I'll put my plus c for everything all at the end and simplify this. So I get 2 over 6, x to the 6 minus 3 over 5, x to the 5th plus 1/3 x cubed minus 7x plus c. And we can simplify this a little more because these have a common multiple, so it's really 1/3 x to the 6 minus 3/5 x to the 5th plus 1/3 x cubed minus 7x plus c. And that's it.